Okay, so we are here. I just explained an example of a MAC address is here, and that it's in hexadecimal numbers. And then we come down here. We one I've already explained. So I've already explained how to get Madam Vero Kulichoni.
Yeah, okay. Okay.
Okay, we continue. So then now we go to layer one. Now layer one deals with the physical things, the all things that we see. And those things that we see are like the copper wires, the optic fiber cables, my cables, my phone, then the coaxial cable. So basically it works, this is what it does, physical thing. So it has to do with how these devices, they send and also receive information. And then it has to deal with the electrical and the physical aspect of the phone, of the network. So therefore, what is physical? Physical, that's why it's called physical. Physical is something you literally see. So my cables, those cables, example, I think there's a time when we talked about cables, sometime when we were starting this course. Yeah. Yes. So if are you able to see my screen on with cables?
Yes, please.
Okay, so this cable like this one, these cables like this, they are all under physical layer. It's a physical. All these cables you are seeing here, all the cables here, they are physical things that we see, physical things we touch. So all those physical things, they fall under layer one. That's where they are.
I think I've only seen two things from here, sir.
Come again?
I think I've only seen two from here, from this that you're showing. The Ethernet cable and USB. The rest, these I've not seen them before.
Oh, you have never seen them before?
No.
Okay. The coaxial cable, you see it every day.
Okay.
Do you still disagree with me?
I still disagree.
You are still disagreeing with me?
Maybe it looks different here. Or it's the name that I don't know.
The coaxial cable. Who can come in here? Who can talk about the coaxial cable?
It's actually the one that they use. Okay, can go on.
The one that they use with the satellite dishes, like DSTV, the cable from the dish to the decoder.
Madam Precious Akafula, you have heard it?
He's breaking. I didn't get anything.
Ija ntambo ija memma connecting ku decoder.
Oh, okay.
Yes, ndiye coaxial cable. Then
Okay,
this
nice.
fiber cable, the fiber cable, you will not see these 1111 the way they are, but at least you have seen this black thing. You have seen this black. Do you agree with me or you disagree with me?
I agree.
You agree where?
Pardon?
Where have you seen them?
Are these not the ordinary cables that we use, like Kaya, so much to explain.
Just no, just stop. Just continue. Just continue. Continue, my dear. But you had already started the sentence. Are the cables we use for what?
I don't know how to explain.
It's not about explaining. It's about how you are going to say what you think, because you say the cables we use. Okay, fine. Without much ado, this cable is the cable we use for fiber. I mean, this cable, you have seen it so many times. It runs on these poles nowadays. As you are moving from Lusaka to anywhere, whichever direction you take, you find that there will be a pole. I mean, there will be poles and one cable running, only one black cable running throughout. Immense cable. That is a fiber cable. Have you seen such before?
No, I thought I did.
Okay. Let me see if I can get a picture. I think the beauty about using internet, what do you call this? The teaching aids are plenty. Okay, fiber cable. Okay, maybe I say how to do. Go for image. You could have seen something like this. These big rows of things.
No, okay, I've seen them.
Yes, you should have seen this. And then it's connected, running maybe from Lusaka to Kitwe. Cable Emos. Now, in that cable Emos, there are so small cables inside each cable. Okay, let me see if there's anywhere where we can find it. Fiber cable on the pole. Yeah. Yeah. This, at times you even see something like this at some point. Have you seen this before now? The one I'm showing?
Mm-hmm.
This installation. So that is a fiber cable. Now, once you see this coil like this, that coil is meant that should the cable cut and they want to join it, they just unroll that piece which is there and then they use it for joining. Now, what about this thing here? What is it used for? That is called the doom join. That's why they join the cable and then put, like the way when you join my cables, yeah, my light, then you put insulation. So here we don't put insulation. Instead, we join them slightly nicely. There's technology that is used in joining them. After joining them, then you protect them using this doom join. I hope I've made it clear.
Yes, sir.
Okay, thank you. Okay, thank you very much. Okay, we can move back to where we were. Okay, so basically, everything that I've talked about there, they fall under what we call the, what do you call this? Physical layer.
Application. The physical layer.
Yes, the physical layer. So they fall under the physical layer. Okay, now, so point number 3 there, bullet number 3, the physical layers connectors. Now we have a lot of connectors for for internet. Let me just see, check around the internet. Connectors. Connectors. Let me say Ethernet connectors. Ethernet connectors. All these are many types of connectors we have in technology. The widely used one is this one here, the RJ45. It's called RJ45. The RJ45. The RJ45 is the one you use for connecting from one computer to the switch. Then, so we have a lot of other connectors. Some are for fiber connectors, and so forth and so on. There are so many of them, so many types of connectors we have. Let me check if I can look around for fiber connectors. Fiber. The fiber connectors, they look like this. This one here. They look like the ones I'm just displaying here. So these are the connectors for fiber. This is how they look like. Okay, so all these fiber connectors, the Ethernet connectors, all of them, they fall under layer 1. And then we have other things about layer 1 is that the other function of this is to change data from frames into bits, zeros and ones. That's a job. That's a job of it. Then also we have machines that are found at layer 1, and that machine is a hub. A hub operates at layer 1. Please take note. Layer 3, what do we find on layer 3? Layer 3, what do we find? What machine do we have at layer 3?
A switch.
A switch. No, not a switch. Sorry, the lady who spoke, it's a router. So here we find a router. Then layer 2, what do we find?
A switch.
A switch.
So let's not forget those. Layer 1, what do we find?
A hub.
A hub. But please, there are many other devices. Now we're talking about communication devices. Communication devices here, a hub. But on layer 1, we also find other connectors, fiber connectors, the way in mulilo, cables, voltage muliro, all those things are under layer 1. Then, so a hub, what is a hub? It's a multi-port repeater. Very good. Multi-port repeater. What does that mean? It means that if you are here on a hub and then you are connected to this hub and you are communicating to another machine and that machine is connected to another hub, when the strength, the signal moves from this computer to another one, by the time it gets to this one, it will be a little bit weak. So it's a job of this other one to boost it, to make it stronger. So that's why a hub is a repeater. So hubs this word where we are no longer using them. They were common those days, but please, they have been replaced. Switches have replaced them. So don't use switches hubs anymore. A hub, the problem it has is a hub receives a signal, and then what does it do? It re-amplifies, it regenerates, it rebuilds that signal, and then what next? Forwards that signal to how many ports? How many ports? All the ports. All the ports. Look at this diagram here. This guy here is communicating, and this is a hub there. Now look where it is sending. It sends to this guy, it sends to this guy, it sends to that guy. All the ports. But if you check switch, it has a MAC address table. But hub baby, what do they do, baby? They just amplify and they send it to all. That's why I told you last time that the way a hub behaves is like the officer that he comes to class bringing a letters. He comes and says, "Who is Benji?" And then Benji raises up and then gives, and then comes back again later. "Who is Benji?" Again, Benji delivers. Again, he comes up. "Who is Benji?" Just like that. You keep on announcing, you keep on broadcasting to everyone. "Who is Benji?" And then Benji raises up, then he walks and then delivers. "Hey, who is Benji?" Just like that. But the switch will memorize where you are seated. You are on desk number 10, it will memorize, and then of course, first time it will use a broadcast. It will say, "Who is Benji?" And once it knows Benji is seated on desk number 10, the next time all the other communications will just be direct. Come to Benji, delivers, go back. Comes from Benji, delivers, go back. Just like that. So, therefore, technically now, let's use technical language. A hub, the problem a hub has is that, last point, a hub will receive a signal and then it will amplify it. It will regenerate that signal. And then what does it do? Forward. It sends it to all the ports. Dear problem. So why does it send to all the ports? Because it does not have a table, a MAC address table. Now tell me, with that kind of behavior, what would be the effect of using a hub on a network? Tell me. Quickly, please, quickly.
I guess there'll be congestion.
There'll be congestion. So a hub, in fact, does not
too much collision. Data collision.
Yes. There'll be both collision and also the what? You remember what I said about a switch? A switch sorts out one thing. What does it sort out between collision and the broadcast? Which one does it sort out? A switch sorts out one of them. Collision and the broadcast. Which one does it sort out?
Collision.
It sorts out collision. But a hub baba kulipi ni kubunkana che vikungo bunkana kulima collision na ma broadcast per hub, making this particular device very slow because there's too much of data losses because ma vikungo bunkana, and then that there's too much congestion because there's too much noise. No? Okay, fine. So a hub doesn't perform any filtering, like I've already explained. It doesn't perform any filtering. This means that all the devices plugged to the hub are in the same collision domain as well as the same broadcast domain. And these collision occur if two or more devices on the same network, they try to send packets at the same time. So since there is no filtering, this type of operation creates what is, listen, another disadvantage is about it, security. Why? Everyone receives, except when it gets to the computer, this computer will check, is this my MAC address? If it's not my MAC address, then it drops. Also this guy, it will say, is this my MAC address? If it's not my MAC address, then it drops. But there are people who are very clever. They can change some few things and then they pretend that they are the actual MAC address being communicated to. And then they begin to receive all your messages. All your messages, they will receive them. So that is the problem. So therefore, a MAC address, or rather, not a MAC address, a switch creates this one. It does not filter. Since it does not filter, then that local area network on which a hub is seated, all the communications there are unsecure. So the last point I say, anyone can sniff the network using some sniffer. And he does what? And encrypt the traffic over that particular. Now, what do we mean by sniffing? There are people who are very crooked. Those people that are hacking into the network, that's what we call sniffing. So they are able to and decipher. Okay, let me show you something here. Let me show you something here. Let me show you this. Okay, here we go. Now, okay. Okay. Now, I have this website which is used for encrypting and decrypting text online. Now, just come to think of it. Somebody is communicating to me, and then he says, "Hi, Mabola. Let's go to town. Let's go to town." Or maybe I'm even sharing certain few secret things, secret things. Now, this guy, can use this one and then say, okay, here, this Mabola, I'll decrypt it. I want you to see what happens. Decrypt, this way the high Mabola will look like this. That is how it will look like when it is decrypted. Now, just imagine, there is somebody in between me, somewhere there, and this person is able to get our communication, get hold of our communication. Is able to get hold of our communication, and when he is going to get this which has been encrypted. Gets it. After getting what has been encrypted, then he comes to this site. And then he comes down here. Do you see there's decrypt? He pastes this and then say decrypt. What will happen here down there? It will display, it will decrypt, it will, meaning it will convert it back to what it was. I don't know why it is taking long. Okay. I'm wondering why it's taking long. It should have decrypted by now. Okay, let me refresh. Let me reload this page. I don't know what's going on. Something could have gone wrong. Okay, let me say hi, Mabola, like that, and then I say encrypt. So this is the result of that encryption, and then I come down here, and then I decrypt. I click on decrypt. There it goes. There it goes. It displays back. So therefore, come to think of it, you are using a hub in that particular network, and then your computer encrypts. Somebody captures this text which has been encrypted. Then he pastes it here. Then it will decrypt it there. You get the point? You get the point?
Yes.
So therefore,
Yes.
hubs are very unsecure. So I've demonstrated this here, and then tomorrow we'll look at what is called the collision. Now we want to go into the depth. Oh, there's still a bit of time. I think we can extend. I don't know. Okay, let's quickly look at collision. Collision domain, because we need to explain now these terminologies. What is a collision domain and what is a broadcast domain? So first of all, we must know that the common networking devices are, we have a router, we have a switch, we have a hub, we have a repeater and a bridge. Repeater and a bridge. Please take note, repeater works at layer 1. A hub is a repeater also. So these two guys, they work at layer 1. So let me put a comma here. This is supposed to be a comma. So these two, they work at layer 1. Then bridge na switch, they work at layer 2. This one is a layer 3. Router is a layer 3 device. So let's take note of that. Now, routers and the switches are perfect because they handle these two problems. First, so now let's understand these two problems. What is collision? Collision refers to a network scenario where one device sends a frame. By now we know what we mean by a frame, or a packet out on a segment on that network. Okay, let's put it that way. Simple language. It sends out on a network. Okay, we have a computer here, and then there's a hub here, or a switch, whatever it is, and they are both here connected. So now, this computer is trying to send something on that particular network. Now, once this computer, which is trying to send something, it will force every other computer on that particular network to pay attention, which means that when this computer here is sending, all other computers must pay attention, must say, okay, the computer number so is sending some information to the other. So let's all pay attention. Let's all be quiet. Let's all make sure that no one else is sending. Now, the reason why all other computers must keep quiet, they must not send, is because they are trying to avoid kubunkana. Because if one computer is sending on another computer sends, they all send at the same time, then there will be collision. So therefore, collision domain is where computers in the same domain can send at the same time and then cause collisions. But where you want to avoid collision is where only one computer can send, all other computers, they do not. So computers are constantly listening whether there's a computer that is sending. Then the point that follows is that this is bad, because if two devices on a single network happen to transmit at the same time, it will cause a collision. And once this collision has happened, then these two devices must retransmit. So think of a collision event as a situation where each device's signal totally interferes with another one. So look at this. Hubs. There is a hub. I mean, there are two hubs in this picture. There is a hub here and another hub over there. These two hubs, they will cause collision domain. They will cause, look at what I've written on top. What I wrote on top is that this is a single collision domain. And also I wrote that this is sorry, not only a collision domain, it's a single broadcast domain, and it's also a single collision domain. Single collision domain, or one collision domain, one broadcast domain. When you are using hubs, it's very dangerous, because even if you connect many of these, you connect a hub here, and then you connect to another hub, and then you connect to another hub, the whole network for your whole school or your whole college or your whole university is like it's one big broadcast domain and one big collision domain. All the traffic there would just be kubunkana throughout. And besides kubunkana, there is too much noise, a lot of noise, like those places where you visit, where we buy those things, market. So when you are using hub, this is what happens. So the hosts connected to each hub are in the same collision domain. So if one of them transmits, all the other must take time to listen for and read the signal that has been sent. So therefore this will begin to cause, since there will be a collision domain, this network will begin to drag. It will become very slow. Now, switches, they solve this problem. They have an advantage over a hub in that they solve the problem of collision, like I already said. Why do they solve the problem of collision? This is what happens. This is what happened. I have a computer here, and this computer is connected to a hub, a switch. The collision domain is just between the computer and the hub. The collision domain is only between between the computer and the port where you have connected, but on a hub, all the computers are in the same collision domain. Take note, please, that a switch makes sure that there is only collision. The collision is between a computer and where it is connected, but on a hub, all the computers, they are all in the same collision domain. I hope this is clear. So messages that are sent from one connected device to a different port, they will never have collision. They will never. So this is quite beneficial. Why? Because there is more bandwidth. Bandwidth means there's more space for other computers also to communicate without disturbing other people. There's more space, which means since there's more bandwidth, then the network behaves a bit faster. Okay. So, however, switches, they don't work, they don't do one thing. Switches, they don't solve one problem. And that problem they don't solve is broadcast domain. They don't. Who solves it? Only the switch can solve a broadcast domain. I will start from here tomorrow since I only have a minute. Any question? Okay, now actually let's say bye-bye because time is up.
Bye-bye.
Bye, thank you.
Good night, everyone.
Okay, thank you very much.
Good night.
So let's try and see. I want that we finish this fast. This course must be put aside. So let's be punctual.
All right, good night. Thank you.
Good night.
Yeah.